Hello, grade nines. Welcome back to another math lesson. We are going to discuss multiplying and dividing polynomials by constant numbers today. So we're going to start with learning how to multiply and divide by constant numbers. And then in our next lesson, which will be on Friday, we'll go over how to multiply and divide polynomials by monomials. So let's hop right into it. A couple things I want to discuss before we get into the new material today. It should go pretty quickly. We only have 2 lessons left in this unit, so just make sure that you are trying to get yourselves all caught up because we will have an end of unit assessment coming up soon. Next week, you'll be getting your next OLA. So we're going to be continuing on with the OLAs. And please do make sure that if you have questions, while I appreciate you reaching out via email, it is a lot easier for me to be able to help you in person. As close to in person as we can get via a live Google Meet. So when I do host those, you don't even have to stop by for more than 5 minutes. Just asking a question, I can help lead you in the right direction. So make sure that you're keeping an eye on those and logging into those when I am having those, okay? Let's move on. So let's talk about today's lesson, multiplying and dividing polynomials by constant numbers. When we're doing this, we use something called the distributive property. Okay, you can do it with algebra tiles, and for the first example, I will show how to do it with algebra tiles, but I don't want us to be using algebra tiles every time. I would rather we knew how to do it symbolically and quantitatively with numbers. So this means that each term of the polynomial inside of the brackets is multiplied by the constant outside of the brackets. This is basically just an application of what we were learning how to do when we had a negative in front of a trinomial or any sort of polynomial inside of a bracket. What happens is this 3 gets multiplied throughout each term. It makes its way throughout each term. And I'm going to show you what this looks like with algebra tiles first. So remember, I'm going to use yellow for positive, red for negative, okay? So for this one, let's draw out what the algebra tile looks like for our term inside the bracket. We have negative 2m. I'm going to draw it horizontal, and I'll show you why after. So there's negative 1m, and there's another negative m. And then beside it, let's put our, those aren't exactly the same size. That's okay. You get the idea. Let's put our positive 4. 1, 2, 3, and 4. Now, if I was going to represent this via algebra tiles, that 3 multiplies by the negative 2m and it multiplies by the negative 4. So I need to draw literally 3 of them. So there's 1 already. Now there's 2. And now there's 3. So that's 1, 2, 3 of the negative 2m's. We'll do 1, 2, 3 of the positive 4's. So there's already one set of positive 4's. There's another set of positive 4. And there's another set of positive 4. What we have here now is this right here is representing negative m. And this is negative m, right, which makes negative 2m. And this is 1, 1, 1, 1. And then right here, having 3 of them is represented by that. So we can just count it out, and that'll give us our final answer. Our final answer will be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6m plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 3 times negative 2m plus 4 is equal to negative 6m plus 12. There's our answer. Okay, now I don't want us to have to do this. Is this a little bit, I feel like this has gotten blurrier. That's better, right? Yes. So I don't want us to have to do this each time. So this is the way that we do it, called, using algebra tiles. Let's do the distributive property now. Okay, let's look at how to do that this way. What you do is you multiply each term inside the bracket by the constant that's outside the bracket. So what this ends up looking like is it looks like, so if I write it all out, 3 times negative 2m plus 4 is going to look like 3 times negative 2m plus 3 times 4. So that 3 makes its way to each term. And then 3 times negative 2, that's negative 6. And 3 times 4, that's 12. So there's our same answer, negative 6m plus 12. There's our same answer, okay? A lot easier, a lot quicker to do it this way. So let's try to get used to doing it this way. Let's do it for this one. So I multiply that negative 2. It's going to multiply through to the n squared, the 2n, and the negative 1. Now, what we have to be careful of now is that there's a negative 2. Negative 2. That negative 2 multiplies the whole way through. So what I'm going to do is I'm going to go negative 2 times negative n squared plus negative 2 times 2n. And then plus, I'm running out of room here, I'm going to write it underneath, plus negative 2 times negative 1. So we take that whole negative 1, that whole negative n squared, and that positive 2n. And we add them all up. So negative 2 times negative n squared, well, let's even just make it a little bit easier for ourselves here. Let's put a 1 there. Negative 1 n squared is what that means. Negative 2 times negative 1, we know is just 2. We get 2n squared plus negative 2 times 2. That's going to be negative 4. I'm going to keep this in brackets because it's a negative. Negative 4n plus negative 2 times negative 1 is positive 2. So I can take that out of its brackets because it's just positive 2. Now we just need to do something about this. A positive and a negative gives us a negative. So this becomes 2n squared minus 4n plus 2. So there you have it. 2n squared minus 4n plus 2. So we take that term that's outside of the bracket and we move it and attach it to each of the terms inside of the bracket. That's the key. Now, a couple things to just be careful of. When there's a negative, make sure you keep a bracket around it so you don't get confused when you're here. And then also when I'm a negative, I'm going to make it a positive, in between the terms and pull that negative 1 so it's also inside the bracket. Okay, so if we're done on that one, let's move on to how do polynomials divide? How can we divide a polynomial by a constant? This one, we've done stuff like this before too. We take each term in the numerator and we divide it by the denominator to create a sum of fractions. That's the goal here, is to create a sum of fractions equivalent to the quotient. Remember, a sum of fractions is just when we're adding up all of the fractions that have the same denominator. So to do A, what I'm going to do is I'm going to take 4s squared minus 8 over 4. I'm going to write it as a sum of two fractions. The one is going to be 4s squared over 4 minus 8 over 4. Now, if you want to, if this is, that minus might trip a couple people up. So what I'm going to do is I'm going to take it, I'm actually going to add them, and I'm going to stick that negative right there. And you can even put brackets around it too. Then you notice to deal with it on its own. Okay? Because we'll see other times when that'll help us. So let's do this now. 4 divided by 4 gives us what? 1. So we get 1s squared plus, what's negative 8 divided by 4? Should be negative 2. So 1s squared plus negative 2. Okay, well, we can get rid of the 1. We never have to write the 1 because the s squared is just right there. And then plus negative 2 is the same thing as minus 2. So after all of that, our answer becomes s squared minus 2. Brief little lesson today. We got one left. Negative 3m squared plus 15mn minus 21n squared divided by or over negative 3. Looks a lot more challenging, follows the exact same steps as the last one. Negative 3m squared over negative 3 plus 15mn over negative 3. Let's put brackets around where our negatives are. Just helps keep things a little bit more clear. Plus negative 21n squared over negative 3. By using brackets, it's now really clear where my double negatives are happening, right? So negative 3 divided by negative 3. We're simplifying all these. That's our last step. Negative 3 divided by negative 3, well, those actually just cancel, right? So we just end up with m squared plus, what's 15 divided by negative 3? Remember, a positive divided by a negative gives us a negative final answer. 15 divided by 3 is 5. So we should get negative 5mn plus negative 21 divided by negative 3. So I immediately see there's negative on the top and the bottom. Those cancel. 21 divided by 3 is 7n squared. We're almost done here. I'm just going to get rid of this bracket and this positive and negative here. I'm going to end up with m squared. A plus and a minus gives us a minus plus 7n squared. M squared minus 5mn plus 7n squared. That's our final answer. Okay? I hope you had some fun trying to solve those rebus puzzles. If you've got any that you want to know the answer to, just, I can post the answers on the classroom. Just make sure that you're asking, okay? Here is your homework problem, homework problems. You'll have tomorrow's lesson to work on these. It does look like it's only 3 questions. It should be a little bit quicker. They're all multi-step problems, though. So especially 15 and 16 will be challenging. Those are the actual ones where you're having to do like what we just did together. Make sure that you're asking me questions. If you have them, you can email me and I will try to get back to you as soon as I can. Usually I can get back to you within an hour, as long as it's between 9 and 4, our regular school hours, okay? I usually get back within a few minutes. So let's, hold on here. What am I? Google Meet, no, oh, I'm sharing my screen. Okay, I don't know how to stop this. Oh, there we go. I was having troubles with it not sending earlier today. I couldn't get one of my videos to upload, but it's working now. So anyways, have a good rest of your day and let me know if you have any questions. We will talk to you later. We've only got one lesson left in this unit, so be prepared for there to be an assessment coming up. We'll see you.